Venus is the most hostile planet in the solar system. Not just hostile, apocalyptic. Surface temperatures of 465 degrees Celsius. Hot enough to melt lead. An atmospheric pressure 92 times greater than Earth's. This is like being crushed under a kilometer of ocean. Clouds made of pure sulfuric acid. No water. No oxygen. Volcanoes everywhere. The Soviet Union sent probes there in the 1970s and 80s. The strongest ones, fully armored, built to survive extreme conditions. They lasted 2 hours. Then they died. So we gave up on Venus. We turned our eyes to Mars. Built plans, wrote roadmaps, launched missions. Mars became the dream, the red planet, humanity's next home. But here's the thing nobody's saying out loud. We might be building on the wrong planet. Now, before you dismiss that, hear this. The reason Venus seems impossible is because we keep imagining standing on its surface. And you're right, the surface is out of the question. But that's not where anyone's proposing to live. The idea is to never touch the surface at all. Because 50 kilometers above the Venusian surface, something strange happens. The temperature drops to a manageable 30 degrees Celsius. The atmospheric pressure equalizes to almost exactly 1 Earth atmosphere, the same as standing at sea level right now. The radiation shielding provided by the atmosphere above is comparable to what we get here on Earth. Gravity sits at 90% of what you feel right now in your chair. This the most Earth-like environment in the solar system, other than Earth itself. That's not a metaphor. That's the actual measurement. 50 kilometers above Venus is more hospitable than the surface of Mars. And here's where it gets truly strange. Jeffrey Landis, a scientist at NASA's Glenn Research Center, was the one who spotted the thing nobody else had noticed. Venus's atmosphere is almost entirely carbon dioxide. Carbon dioxide is heavy. Oxygen and nitrogen, the air we breathe, are lighter than carbon dioxide. Which means on Venus, a balloon filled with regular air doesn't need helium to float. It just floats on its own. Because our air is literally lighter than Venusian air. Let that sink in. Take the room you're sitting in right now. Replace the walls with something thin and airtight. On Venus, that room would rise into the sky. The air itself is the lifting gas. Landis calculated the numbers. A spherical balloon 1 kilometer in diameter would lift 700,000 tons. 2 Empire State Buildings. What about a 2-kilometer balloon? 6 million tons. You're not building a tiny research station. You're building a city. Tens of thousands of people. Floating. Supported by nothing but breathable air in a CO2 atmosphere. That's not science fiction. That's physics. But wait, what happens when the balloon tears? Because this is the question everyone asks, and the answer is counterintuitive. Nothing catastrophic. Because the pressure inside and outside the balloon is nearly identical, a rip doesn't cause explosive decompression. There's no pressure differential forcing the air out. It seeps, slowly, like opening a window. The bigger the habitat, the slower the process. A city-scale balloon would give you hours, maybe days, to repair damage before it became critical. Compare that to Mars, where a puncture in a habitat wall would violently blast oxygen into near vacuum. Ironically, the math is actually safer on Venus. Now, the sulfuric acid clouds, those are real, corrosive, dangerous. But the Soviets already solved this in 1985 when the Vega mission floated 2 balloons in the Venusian atmosphere for 2 days. The outer layer? Teflon. Just Teflon. The stuff already in your kitchen. Completely resistant to sulfuric acid. The problem we thought would kill this idea was already solved 40 years ago. Here's where the story turns uncomfortable. The winds on Venus move at up to 350 kilometers per hour. They circle the entire planet every 4 Earth days, a phenomenon called super-rotation. You'd be riding a continuous hurricane, never stopping, and the Venusian day lasts 117 Earth days. Half of that is darkness, pitch black, no solar power, 58 days at a time. These aren't minor engineering challenges. These are civilization-scale problems. But here's what the numbers say when you compare Venus to Mars side by side. Mars' gravity is 38% of Earth's. Astronauts lose up to 1% bone density per month there. Venus floats you at 90% Earth gravity. Your body doesn't even notice the difference. Mars has almost no atmosphere. Solar radiation hits the surface essentially unfiltered. Venus's thick cloud cover provides radiation shielding equivalent to Earth's. You'd get the same exposure floating in the Venusian sky as you would walking around in Canada. Mars is 55 million kilometers from Earth at closest approach. Venus is 38 million. Getting there is shorter, cheaper, and requires less fuel. And Venus gets 4 times more solar energy than Mars. 4 times. Every metric that matters for long-term human survival. Gravity, radiation, distance, energy. Venus either matches or beats Mars. The one advantage Mars has is a surface, a place to stand. And that's exactly why it's winning. Not because the science is better, but because of something deeper. Humans have always planted flags on solid ground. The idea of a colony you can't physically stand on feels less real, less conquerable. It shouldn't, though. NASA actually started taking this seriously. In 2015, the Langley Research Center developed HAVOC, High-Altitude Venus Operational Concept, a 5-phase program. First, a robot, then crewed orbital missions, then crewed atmospheric missions, then a year in the atmosphere, then permanent habitation. The airships they designed were 130 meters long, solar-powered, acid-resistant, capable of keeping 2 astronauts alive in the Venusian clouds for 30 days. Multiple upcoming missions are already headed there. Da Vinci, targeting launch in the early 2030s, will send a probe directly through Venus's atmosphere to measure its composition layer by layer. Envision, an ESA mission planned for 2031, will map the surface and study atmospheric dynamics. The data is coming. The roadmap exists. But the funding goes to Mars. For now. But here's the real picture. Nobody is building a floating city on Venus this century. The engineering problems are real, the costs are enormous, and humanity is still figuring out how to keep a few people alive on the moon. Just think about what we're actually describing. Cities floating in the clouds of another world. Hundreds of thousands of people living, working, raising families 50 kilometers above the most hellish surface in the solar system, sustained by nothing more than the physics of air pressure and the ingenuity of people who refused to accept the obvious answer. Yes, it sounds insane. So did every other thing we've ever done. The history of humanity is a list of things that shouldn't have been possible until they were. And the further we push into the future, the stranger that list becomes. Floating cities on Venus won't be the last impossible thing we build. It might just be the next one. the next milestone. But until then, if stories like this make you think about what's possible, hit subscribe. There's a lot more out there at the edge. We are just getting started.